Today's lesson is your review for quiz 1-1. The first question on our quiz today is going to ask you to complete the following table. You're going to have a different thing given to you, like an inequality, interval notation, and set builder notation. You are going to have to fill in the missing blanks. So let's go ahead and start with the first one. When you have an inequality given to you, you can go ahead and do the graph and set builder notation first. And of course, interval notation, we can either read from the graph or we can read from the inequality. So I like to do things in order from left to right. So I'm going to go ahead and take this inequality and put it over on the graph. The two numbers that must show up on my graph are -3 and 5. So I'm going to go ahead and start by placing my 0. And then I could just make another mark and call it -3. And then I could make a mark and call it 5. Now, if I really wanted to, I could go ahead and go 1, 2, 3, and 4. And I could go -1 and -2. I could add some extra marks as well. Now, the circles need to be at -3 and +5. The circle at -3 is going to follow this inequality. Notice that this inequality has a bar underneath it. It has the or equal to. That means when I put the circle at -3, it must be closed. This symbol here goes with the 5, and since it does not have a bar on it, that means the circle at the 5 needs to be left open. Because it is a compound inequality and I see two less than symbols and the variable x in between, I'm going to simply go ahead and shade in between them. Now I can easily see the interval notation, and of course set builder notation I'm going to use the inequality for. So set builder notation, I already know it's going to start with the squiggle, the variable x, and the horizontal line, or sorry, the vertical line. That means all real numbers, all real numbers x, or all the values of x, that. And then I'm just going to go ahead and copy the inequality that was given to me. Now for the interval notation, I'm going to go ahead and use my graph. Remember, you need to start here on the left side and start reading towards the right. This should be the first number you put, and then this should be the last number that you put. So there we go. Go back and look at the -3. It is closed, so we're going to go ahead and use a bracket. And the 5 is open, so we're going to go ahead and use a parentheses, because opens parentheses, closed is bracket. All right, let's go ahead and take a look at the second one. Notice they gave us the interval notation. From the interval notation, I could go ahead and do the graph. So it looks like I'm going to start with my point at the 12. My point is going to be closed because of the bracket, and my point is going to start at 12, be closed, and it's never going to end because it's heading towards positive infinity. So, that's a lot of numbers. I think I'm just going to go and put like a bunch of marks. It's nice to see 0. We don't have to see 0. I'm going to go ahead and make that one be 12. Remember, we already talked about it's going to be a closed dot, and we're going to shade on forever to positive infinity. All right, what would that look like as an inequality? Well, x is going to be what to 12? Are these numbers on this line smaller or bigger than 12? That's what you're really asking yourself. Well, what number's right next to it? 13, then 14, then 15. We're getting bigger, so it's going to be greater than. The 12 is closed, so we're going to add the or equal to. Now that we know the inequality, we're simply going to put the set builder notation with it, all values of x such that, there we go, I got it right this time. And I'm going to copy down my inequality. All right, the last one may be the trickiest. They gave you set builder, although I think that second one was the trickiest. The reason this one might not be so tricky is because this is my inequality. So there's my answer for this one. Now I know how to do my graph. I need to put the circle at 3. It needs to be open because there's no bar. And no, remember, I told you guys that when it's like this, it's pointing. So I know I'm shading towards negative infinity. So I could put 0 this time because it's just 1, 2, 3. And then I could put some other negative numbers. Maybe I could label -3 as well. We have an open circle at 3, and we said we were going to shade on towards negative infinity. Please just make sure that I can see your shading and I know which way you're heading. Okay, so it would be for interval notation negative infinity, comma, +3. Remember, infinity, both positive and negative, always gets a parenthesis. And the 3 is open in my graph, so it's going to get a parenthesis as well. All right, question number 2 is going to ask you a bunch of different questions. It's actually going to count as more than just question 2. It's going to be 2, 3, 4, 5, 6, 7. So each one is going to count as its own separate question. You will be given a graph similar to this, and you're going to be asked for domain, range, global maxima, global minima, and local minima. You will be asked to do one in interval notation and the other in set builder. Please make sure that you read. All right, here we go. Domain. Remember that your domain are your x values right here. And so you're reading your graph from the left to the right. Remember, over here on the left side, as you read towards the right, you have negative infinity. And then over here on the right side, you have positive infinity. Now, to be able to use the infinities, remember the ends of your graphs have to have arrows to showing that they are continuing forever and ever. Now, this particular graph has an open circle right here. I'm just going to pull it up to the x-axis to see what its number is. It's going to be right here at -8. So there's the first number I see, not the negative infinity, the -8. So if I really wanted to, I could come back over here and erase that negative infinity because I'm not going to use it for this problem. Or I could just kind of scribble it out. All right, then I'm going to scan my graph to the right. There's graph, 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 and then it ends right here at this point, this closed point. I'm going to pull it up here. It looks like it's at 5. So I'm going to close this point right here at 5. That graph that went up and down is going to go ahead and it's going to squeeze in between these two numbers. Remember, it's always the easiest to do interval notation first and then to go ahead and do your set builder notation. Because once you have interval, you can do the set builder. Remember, I showed you those little tricks. So interval notation, I'm going to read the number to the left, which would be -8. I'm going to put a comma and I'm going to read until I get to that last circle. Remember, this one is gone because this graph has a beginning and an end. It does not have, it doesn't continue infinitely. And I'm going to go ahead and put 5. I'm going to go back and look at the circle at 8. I'm going to look here. I'm going to look here. They're the same circle. I just pulled it up into the x-axis. It is open, so I'm going to put a parenthesis. And likewise, I'm going to put here look here at 5 and here. They're the same one. I just pulled it up and I'm going to put a bracket. And that's it. That's my interval notation. Remember, when you have an interval notation like this and you're doing set builder, then you make a compound inequality, much like we saw in the very first one in the table in question number 1. All right, let's go ahead and look at the range. Now remember that the range are your y values. So I'm going to highlight my y-axis. Some things that we need to be looking for when we're doing the range. Remember, we start down here at the bottom, which is where our negative infinity is, and we're going to read our graph in an upwards direction until we get to the top of the graph, which is where our positive infinity is at. All right, so if I read my graph up from the bottom, and I'm just kind of scanning, there is nothing in this area. The first point I see appears to be this one right here. Yes, so I can kind of draw a horizontal line to make sure that that is the lowest point. And then if I look up here, this appears to be the highest point. So those are the 2 points that I'm going to use. This point right here is going to come over to the y-axis and it'll stay closed right here at -4. So I'm going to go ahead and put it, and I'm going to go ahead and make this -4 stand out a little more. This point here at the top is closed because there's continuality between my 2 endpoints. If I want it to be open, I need to show you just like I did right here. So I'm going to pull this point right here over to the y-axis. I'm going to keep it closed, and I'm going to say 9 because it's right in between 8 and 10. What this graph is going to do in between all these points, including this open one, are going to come and squish in together and to fill up this space right here. There we go. Now remember, you're reading from bottom to top. Now it does want set builder notation, but I would do the interval notation first and then go ahead and do your set builder. Remember, set builder is the one with the squiggle. We are talking about range, so make sure you use the letter Y because that's your variable for range, and then you're such that. Now I'm going to do the interval notation first, even though it's not the answer that I'm looking for. So you will get all your points taken off if you do use the wrong form. I'm going to put the bottom number that I see. Remember, it's not negative infinity, and we're not using positive infinity because this graph is going between 9 and -4. So I would put -4 first because it's towards the bottom, comma 9. Both of them are closed. Look at both of them. Both of them are closed. So I'm going to go ahead and use a bracket and a bracket. So remember, just like I said with the last one, when you have two numbers, -4 and +9, you are going to make a compound inequality. Okay, there's your spacing for your compound inequality. The first number, leave a space, y, leave a space, the last number. Now, if I flip it to domain, the only difference there is that you need to use the -8 and the +5 and the variable x because that's the letter that we use when we're talking about domain. I always use the symbol less than when I'm doing a compound inequality. Okay, that's always the one that we use. And then I'm going to go back and look at at my um, at my points at -4 and +9 to see if they're opened or closed. Remember, you can also look at your brackets or your parentheses. Since we have closed points and they both contain a bracket, I'm going to put the or equal to bar, and I need to finish with a squiggle at the end. All right, remember in my graph that I have maxima high points and minima low points. When I'm talking about them, I'm looking for the y values. So I always have to give the y values when I'm talking about a maxima, a max, or a minima, a min. Now, global means that we are at the highest point. So I'm going to go ahead and grab this. And we're going to talk about them twice, but we're going to talk about them as being global the highest and local just higher than other points. So as I read my graph, I'm starting here and I'm going up. And when I get to a peak, I have reached a max. So this would be a max. And then I turn and go in the opposite direction. When I get to this peak here, this would be a min because it's smaller, it's lower than this first peak. Then I'm turning and going upwards to a new peak, max. And then I'm going downward and I'm ending at a min. Okay. Um, you could think of this starting point as a minimum because it's lower than this first maximum right here. So if I look for my maxima, I had a max here and a max here. Okay. Now I'm just going to go ahead and identify them as maxima right now I'm just going to call it a max. And then I'm going to look at them and say, which one is the highest? Which one is higher than the other one? That one's going to be my global. Well, that would be this one right here. This one's going to be my global max. And I just need to know its Y value. If I head right over there, it's going to be 9. So there's my first answer. I'll go ahead and put it in the purple. This other max that I have is going to be a local max. And so I just need to figure out what its Y value is. Go to the green, 6. Could there be more than one? Yes. You could separate them with a comma. You could separate them with the and symbol. All right, let's go ahead and look at our minima. These are the points that are lower, that peak lower, like this one. This one was a min. And this one was a min. And we could even say, well, it's not a point, but we could even say this one is a min. It's open, so maybe we shouldn't say that one, huh? Which one is the lowest? Which one is the lowest? I would say this one right here. So I need to know its Y value because this is going to be my global. And so all I have to do is follow it over -4. There can only be one global, okay? There can only be one global. Local. The local is going to for sure be this one. And I'm going to come over here. It's right between the 4 and the 2, so I'm going to go ahead and say 3. And now I have to make a decision. Is this a minimum? If you say yes, your answer would be -2. I'm leaning towards no because this is an open circle. Okay, this is an open circle, so I'm going to lean towards no. I'm going to go ahead and look it up after the video for today, though, and I'm going to add some notes in your Schoology section if I'm not correct. But I'm going to say this is not a minimum because the circle is open. And so technically there's really not a point there. It's kind of just starting and it's getting close to that -2 Y value, but it's not really there. That's what that open circle means. So I'm going to go ahead and say no. But if I'm wrong, I'm going to look it up. If I'm wrong, I'm going to go ahead and add those notes to your Schoology and I'll let you guys know in class. All right, let's take a look at the next question. The next question is going to just have you evaluate the function below for a given f of number. Now this one is f of -2. Remember for this one, you're just going into the calculator. You are taking this expression right here. Remember in class we boxed it in the gray box? And you're just going to be replacing the x value with the given value. So for this f of -2, remember this means that your x values are changing to -2 throughout that gray boxed function. That f of x part does not go into the calculator. This right here does not go into the calculator. It's simply allowing you to know what to substitute. What goes in my calculator? -3, parentheses, -2, close parentheses, to the squared power, minus 5 times parentheses, -2, close it up, plus 10. I'm going to go ahead and hit enter. I'm going to go ahead and enter this into my calculator because I don't know what that is off the top of my head. And I'm going to get my answer. So give me one sec here. I got 8. And just like that. All right. The next question you will see will ask you to evaluate a function just like the one we did. However, this one is going to be with a graph. So just remember that this means x equals 1. So you're going to go find the x-axis and you're going to find the number 1. I'm going to put a little gray dot there. And let me use my laser because I know it's kind of hard to see. There's my gray dot at x equals 1. I now need to find my graph. I just simply ask myself, where's the graph? Is it above this point or below this point? Well, there's nothing below this point, so the graph has to be above it. Maybe it's to the left side, maybe it's to the right side, but it should be above or below it. There it is, right? There's my graph. So all I have to do is take this point at 1, and I'm going to go up until I hit the graph. Then I simply go over to the y-axis. That is my answer, and it looks like 2. That's it. If you want to make sure that you get full credit for this one, just in case you're reading it wrong, what you might want to do is, see how I put the dot? You might want to show me that you pulled it up, and then maybe show me that you pulled it over. Okay? You could do something like that. This just ensures that you and I are thinking the same thing. All right, and the last question on your quiz today is going to ask you if the following relation is a function. Now remember, your function, your relation will be a set of ordered pairs. It might have more than what I have here, but remember every ordered pair has an x value. These are the first numbers, the left number that you see in the ordered pair, and a y value. These are the second numbers or the right number, the right side number as you look at the ordered pair. All you have to remember is which one do you look at to not repeat? Which one cannot repeat? Well, X cannot repeat. Okay, X cannot repeat. So I'm going to go ahead and I'm going to look at all of these X values, and I want to make sure that all 4 of them, 1, 2, 3, 4, are different. Well, the thing that I notice, the first one is -1, the last one is -1. Is this a function? No. You don't have to explain why, but I want to explain to you that the reason this is not a function is because I have a -1 for the first ordered pair and I have a -1 for the last ordered pair. Good luck on your quiz.